Hello, everyone. All right, today we're going to be talking about terminating and repeating decimals. You already actually know how to do this. We're just going to add a little bit to it, which includes the repeating decimal piece to it. So we have decimals. We know how to change our fractions to decimals. Fractions to decimals, we are simply just doing the numerator divided by the denominator. What we haven't had so far this year is we have not had where we have an answer that gives us a repeating decimal. So we want to start talking about how we can write repeating decimals using what's called bar notation. And so let's first review what is a repeating decimal and what is a terminating decimal. So a repeating decimal looks very similar to this. 0.3333333333333, where the 3 is repeating, and that's where it gets its name, repeating. It's where I have a decimal that repeats. This is an example of a repeating decimal. This right here where you see 0.625, and then it just stops, that's an example of a terminating decimal because it ends, it terminates. Technically, these decimals, I could write zeros that go on forever, and so therefore it technically has a 0 that repeats. However, when we start to write these answers, we don't write the 0 repeating. We simply just write all the way up until the non-zero numbers. So what are examples of terminating decimals? Well, an example would be 0.4, 4/10. An example of a repeating decimal, maybe something like 0.43434343, and it would have to go on forever. So today we're going to learn how to write this number, this repeating decimal, and using what's called bar notation. So let's go ahead, let's turn the page. Some vocabulary terms that you need to know is you need to know that a rational number is any number that can be written as a fraction. And so when I'm looking at my numbers, in order to determine if it's rational, I determine if it can be written as a fraction. All fractions are rational numbers, repeating decimals are rational numbers, and terminating decimals are rational numbers. All three of those things are considered to be rational numbers. Rational numbers can be positive or negative. The only ones that are irrational are those that do not repeat and go on forever. An example would be like pi. So, like I said earlier, we're going to be using what's called bar notation. Bar notation is where I put a bar over the digits that repeat. So, it's this line right here. Do you see that line above the 5, 4? That line is called bar notation. So if I look, I have 0.54545454. Well, another way to write that is using bar notation with 0.54 with the line over the 5, 4. Sometimes we get decimals where some of the digits don't repeat and then some of them do. So what we do for a problem like this is I would write my answer 0.583 with the line just over the 3. And that tells whoever's looking at my paper, the 5 and the 8 don't repeat, but the 3 does. And that's important for them to know. So let's look at example 1, 5/12. Now, I am allowing you to use a calculator, so what you do is you divide 5 divided by 12. So I literally am you're allowed to use a calculator, so we get to do 5 divided by 12. You will get this crazy number. You'll notice that it actually has a 7 at the end on some of your calculators, and the only reason it does that is because it rounded. Please ignore that last digit on your calculator. You will see that it goes 4166666666666. So to write my answer, I write 0.41 with just the 6 repeating. All right. Let's try one. I want you to go ahead. I want you to try A, B, and C. What do you think you get? Go ahead and give them a try. Okay. So for letters A, B, and C, you should have gotten 0.16 with the line just over the 6. For B, 0.8 with the line just or only over the 8. And then C is 0.18 with the line over both of them. And again, to find those, you should have done 1 divided by 6, 8 divided by 9, 2 divided by 11. All right, let's keep going. So what happens when there's a negative involved? When we have a negative as a fraction? Nothing. We do the exact same thing, except we just make sure that we have a negative in our answer. So, for example, they also, for this one, they had -2/9. They got 0.2 repeating. So they wrote -0.2 with the line over 2. What happens when there's a whole number? People always get so nervous when they see whole numbers. It doesn't make any difference. So what I do for this one is I simply take my 2. You could change it into an improper fraction and then divide. That's what the book did here. The other way that you could have done it is you could have said, well, it has -2, so I know it's going to be negative. I know it's going to be -2 point. And then whatever I get here, 2 divided by 3, which gets me 0.6666666. So I would take that 0.6 and write it 0.6 repeating. So again, let's go ahead and try D, E, and F. For D, I have -1 divided by 4. I get 0.25. But don't forget, it's negative. 5 divided by 6. If I type that in, what do you get? You get -0.83 with just the 3 repeating. -2 1/6. So what I would do is I simply would write my -2, and then I would do 1 divided by 6, which gets me 0.16 with the 6 repeating.